Hi, my name is Tom Catalan Wilson. My ZID is Z5371164, and this is my student ID card. Understanding the solar system. Let's first begin with discussing what are Kepler's laws. Kepler's laws of planetary motion are three fundamental principles that describe the motion of planets around the Sun. They were formulated by the German astronomer Johannes Kepler in the early 17th century based on observations made by Tycho Brahe. These laws played a crucial role in revolutionizing our understanding of the solar system and laid the groundwork for Isaac Newton's law of universal gravitation. Continuing on, in question 9, we are asked to compare the scenarios observed in questions 1, 4, and 7. In the simulation for question 9, unlike what is seen in the earlier simulations with the Sun and Earth, the lesser ratio of mass between Earth and the Moon shows obvious signs of movement in the planet. This is because the ratio of mass between these two bodies is significantly less than that of the former, and as such, the Earth is visibly impacted by the gravity of the orbiting Moon, as the Moon's subjected gravity has a larger effect on the comparatively lesser mass of the Earth. As for the centers of mass in these questions, due to the significantly larger mass of the Sun in comparison to the orbiting planetary body, the center of mass for questions 1, 4, and 7 are all very close to the center of orbit. As the orbital path for question 7 is considerably shorter than in questions 1 and 4, its center of mass is therefore slightly closer to the center of the Sun in comparison to questions 1 and 4. Moving on, for questions 11, as can be seen in the attached image, the distance covered for each grid area is approximately equal to 73,336,625 kilometers, which when converted to astronomical units is approximately equal to 0.49 AU. For question 14, Kepler's third law, also known as the law of harmonies, states that the square of the orbital period of a planet is directly proportional to the cube of its semi-major axes, otherwise known as the average distance from the Sun. In this law, t squared represents the orbital period squared, and a cubed represents the semi-major axis cubed. The constant k is the same for all planets in the solar system and remains constant for a given system of units. As can be seen in the provided table, a clear correlation between the recorded values of the orbital period, distance of the planet, and the application of Kepler's third law exists. Although there is an error in all the calculated values, most likely attributable to the incorrect timing of the orbits in the PHYS simulation or the incorrect distance measurement of the grid overlay, the results are close enough to understand and observe Kepler's third law. Answering question 15, among the planets in our solar system, Mercury is expected to have the fastest orbital velocity as it is the closest planet to the Sun. This proximity results in a much stronger gravitational pull compared to the other planets. Contrarily, Neptune is the farthest away from the Sun, and being at such a great distance, it experiences a weaker gravitational pull. Kepler's second law, also known as the law of equal areas, states that a planet sweeps out equal areas in equal times as it orbits the Sun. This means that a planet moves faster when it is closer and slower when it is farther away. Mercury therefore has the fastest velocity, whilst Neptune has the slowest. What did I learn during this assessment? Having studied physics in high school during years 11 and 12, it was a nice bit of nostalgia covering Kepler's laws again and how they relate to our very own solar system. In this experiment, I was reminded of the effects of gravity on all orbiting bodies, how the velocity and distance of an orbiting body affects its path, and ultimately how Kepler's laws are attributable to the motion of all planetary bodies in the universe. Despite some inconsistencies in the PHYS simulation, all relevant points were successfully translated from a theoretical understanding to a practical observation. In completing this assessment task, I feel that I have gained a greater understanding of the universe as well as a greater sense of wonder. I very much look forward to continuing my astronomy journey and thank the whole PHYS1160 staff for inspiring me throughout the term. Thank you for listening to my presentation.